Floyd Warshalls algorithm. And this algorithm is used for finding all pair shortest path. And we are trying to solve this problem using dynamic programming strategy. Now, what dynamic programming states is, dynamic programming is a design strategy in which the intermediate results of the calculations or the operations are stored explicitly and then used for the further calculation. It is nothing but a kind of a optimization problem, just similar to that of divide and conquer, but it solves the problem by combining the solution of subproblems. But for each subproblem, it will store the results or the intermediate results in some of the other form, and that those intermediate results will be used for solving further subproblems. So you can consider it like this: if this is a problem, this problem will be divided into two problems. This is divide and conquer, right? Remember this thing?
Yes, sir.
Yes, sir.
But in this case, this subproblem might have some solution and this subproblem also have some solution, but these two solutions are not interrelated. This is solution 2, this is solution 1. But these two are not interrelated. Whereas in case of dynamic programming, all the intermediate solutions are interrelated. So if this is your bigger problem, let's say this is P1, then whatever output P1 will generate, that output will act as an input to P2 for problem P2. P2 solution will be used in some other subproblem. So here what we are doing is we are trying to improve the performance of the problems in terms of their time complexity by storing the intermediate results, so that at the end whatever result you get is the final result. Whereas in case of divide and conquer, after dividing all these things, whatever solution you get, those solutions have to be again merged back into a single solution. याद आ रहा है क्या?
Yes, sir.
Right? So डायनेमिक प्रोग्रामिंग का अगर मैं एक सिंपल स्टेटमेंट में आपको बताऊं तो वो होगा कि dynamic programming solves each subproblem just once and then saves its answer and then stores the answer for further calculations. So this provides us with not recomputing the answers every time we reach to that sub problem. मतलब आप जब उस सब प्रॉब्लम पे जाते हो तो हर बार आपको उसको रिकम्प्यूट नहीं करना पड़ेगा, एक बार कंप्यूट करके यू विल स्टोर इट. सो अल्टीमेटली जब आप उस पे जाओगे तो यू विल डायरेक्टली यूज द फाइनल सॉल्यूशन. So rather than recomputing it again and again. That is dynamic programming. So what is happening here is at dynamic time, you are getting you are storing the results, and then at dynamic time itself, you will be using these results for your purpose. ये समझ में आया इतना? डायनामिक प्रोग्रामिंग का मतलब क्या है? Please let me know if you haven't understood this.
Yes, sir, understood.
Sorry.
So understood.
Okay. Everyone else also have understood?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, fine. So now let us take an example. And now what we will be doing is we will be applying this dynamic programming on a graph in order to calculate the shortest path from all the nodes to the other node. Okay. So let's say this is my graph. What is a weighted graph?
Whose edges have a weight?
Which the edges, if have some weights, it is weighted graph. What is a directed graph?
When the
And
Have
edges.
directions.
So is this graph is directed or undirected?
directed.
Direct.
Okay, at least you know this thing. Can the weights be negative also?
No, sir.
No,
Why?
So they can be negative.
They can be,
But they cannot be solved by Dijkstra's, the negative weights.
The weights cannot be solved by Dijkstra's if they are negative. This graph, I'm taking the example of negative weights also. So 1 to 2, any edge if not connected, please check. And every edge should have some weight. Have I given everything some weight?
Yes, sir.
Yes.
Okay. Now, can I convert this into a matrix?
yes, sir.
Yes, sir.
Yes, sir.
You know the process,
Yes, sir.
Yes, sir.
how to convert it. Do it in a notebook also, parallelly if you can. And those who don't know, please concentrate on the whiteboard. So I am calculating it as A0. How many columns will I have? 1, 2, 3, 4, 5. Because there are 5 nodes. So 5 rows and 5 columns. What should I fill in these nodes?
wait,
Weights, right? So 1 to 1, how much cost is required? What is the weight to reach from 1 to 1?
0.
1 to 1 is 0. 1 to 2,
3.
3.
3. 1 to 3,
8.
8. 1 to 4,
0.
can I reach from 1 to 4?
No.
No. Should I write it 0?
Yes.
Should I write it 0?
Yes, sir.
See, it is like in this graph, if somebody starts traveling from node 1, how much distance will it cover to reach node 1 again? 0, because we are already standing on that node. ये समझ में आया कि 1 से 1 जाने के लिए 0 कॉस्ट लग रहा है क्योंकि हम ऑलरेडी उसी नोड पर है. बट 1 to 4 जाने के लिए इफ यू डोंट हैव एन एज, does it means that it is 0? Can't I reach 4 via something else?
Yes, sir, we can, but in the graph we write it 0.
As per the graph, we cannot. But yes, if I start traversing via some other node, I can reach 4. That
Yes,
means,
sir.
can I say that at this point of time or at this instance of the graph, 1 to 4 is infinite? I don't know whether I will reach or not, but I may reach if I travel via some other node. Can I write infinite?
No, sir, I didn't understood that.
देखो, मैं 1 से 4 तक नहीं जा सकता हूं, बट ये पॉसिबल है कि मैं 1 से 4 वाया सम अदर नोड जाऊं, लाइक 1 to 2 एंड 2 to 4. जा सकते हैं क्या?
Yes, sir.
1 to 4 का डायरेक्ट पाथ अवेलेबल नहीं है, लेकिन मैं 1 से 2 और फिर 2 से 4 जा सकता हूं.
Yes, sir.
Yes, sir.
फाल्गुनी,
Yes, sir.
जा सकते हैं, राइट? बट अभी इस इंस्टेंस पर मैं नहीं जा पा रहा हूं, तो मैं अभी क्या कर रहा हूं, A0 मैट्रिक्स बना रहा हूं, द इनिशियल मैट्रिक्स. और इनिशियल मैट्रिक्स में हम क्या कर रहे हैं, इनिशियल मैट्रिक्स में हम वो सारी चीजें एज इट इज पुट अप कर रहे हैं जो हमारे पास ग्राफ में दी हुई है. एज पर दैट 1 to 4 कैन बी रीच्ड via some other node. So, but I don't know how much cost it will acquire. So I have written infinite. Now we will calculate this infinite. We will replace this infinite with some other values in the coming calculations. अभी समझे क्या?
Okay, sir. हाँ, sir.
Okay, so 1 to 5 minus 4. Likewise, if I fill this entire matrix, I'll find 2 to 1 is no directed edge.
Infinite.
So infinite 0,
0,
infinite 1,
1,
7.
7.
Just verify this in your diagram. And if you are not able to find out why these values are returned, please ask me. I'm writing them just to save time now. Everybody got this matrix?
Yes, sir.
Fine. Now what objective we have here is we need to find out the shortest path from all the pairs. So all pair shortest path का मतलब होगा 1 to 2 जाने के लिए shortest path कितना होगा, 1 to 3 के लिए shortest path, 1 to 4 के लिए, 1 to 5 के लिए, then 2 to 1 के लिए, 2 to 3 के लिए, 2 to 4 के लिए, 2 to 5 के लिए, then 3 to 3, 3 to 1, 3 to 2, 3 to 4, 3 to 5. Likewise, among all the pairs of the nodes, I want to calculate the shortest path. Okay, what we will do in order to do this, we will start with one of the node, any node. We'll start with one of the node and we'll try to apply dynamic programming over it. Okay, so let's try it. Let's calculate the things. I'll form a next matrix which is A1. Now A1 matrix is for node 1. अगर नोड 1 के लिए मैट्रिक्स बना रहे हो आप, तो नोड 1 के जो रोज और कॉलम्स है, दोज विल बी अनटच्ड. वो तो वैसे के वैसे ही रहेंगे जो मैट्रिक्स A0 में है. मतलब 1 से 1 जाने के लिए जो कॉस्ट है वो तो सेम रहेगा ना. 1 से 1, 1 से 2, 1 से
Yes.
3, 1 से 4 और 1 से 5, ये कॉस्ट चेंज होगा क्या इफ यू आर स्टार्टिंग फ्रॉम 1?
No, sir.
Abhijit, are you getting this?
Yeah, sir.
So can I just copy those values here? Like 1 to 1 is 0, 1 to 2 is 3, 1 to 8 is 1 to 3 is 8, 1 to 4 is infinite, 1 to 5 is -4, and the same column जो जहां जहां पर 1 मेरा आ रहा है वो सारे columns as it is रहेंगे. So 1 to 1 is 0, 1 to 2, that or maybe 2 to 1 is infinite, 3 to 1 is also infinite, 4 to 1 is 2, and 5 to 1 is infinite. Also, all the diagonal will be 0 because reaching from the same node, starting from the same node and reaching on the same node is 0 always. So this will be also 0.
Yes.
1 to 1 will be 0, 2 to 2 will be 0, 3 to 3 will be 0, 4 to 4 will be 0, and 5 to 5 will be 0. ये इतना समझ में आया? इशिता, अनिरुद्ध तो है नहीं आज.
Yes, sir.
सुमेश, अनुष्का, अभिजीत, अक्षत.
Yes, sir.
Yeah, sir.
इतना समझ में आता है? ये मैंने कैसे बनाया इतना? Simple, what we have done is wherever 1 is there, because this is for node 1, this is at node 1, so wherever 1 is there I have just copied the previous values. Now the remaining values we need to calculate. So let's start with the calculation for okay, so let's try it. We need to calculate a 2 3 A matrix में 2 and 3. So basically this value we are calculating. ठीक है?
Yes, sir.
Okay. Now, because this matrix is for node 1, I need to calculate the path for 2 to 3 via 1. मतलब I need to reach to this nodes via 1 only. ये फिक्स है क्योंकि हम नोड 1 के लिए मैट्रिक्स बना रहे हैं. Similarly, we will create matrix for node 2, node 3, node 4, node 5, and so on. So if A2 3 I need to calculate, so this 2 3 will acquire some cost 2 to 3. And other way of reaching to 2 to 3 is what? Via 1.
Yes, sir.
Can I say it like A of
Yes, sir.
2 to 1 plus A of 2 to 3? देखो 2 से 3 नोड 2 to 3 requires some cost, but 2 to 3 जाने के लिए I can have multiple options. I can directly go from 2 to 3. I can go 2 to 3 via some other node also. But right now in this graph, 2 to 3 is infinite. So this is infinite.
So, but the direction is
Sir,
opposite.
that second term should be 3 to 1 or 1 to 3.
1 to 3.
The second term
sorry,
which is
sure.
written in addition.
Yes. This has to be 1 to 3.
And so we cannot go from 2 to 1
We
directly because it's directed.
Means,
Like it's directed in direction from 1 to 2, not 2 to 1.
yeah, so directions and all, we are not, see, let me rub this. We are going by procedure, right? So with procedure, what I need to calculate? A2 of 3. So either I can reach A2 of 3, or I can go from A of 2 to 1 and 1 to 3. 2 to 3 is infinite because there is no directed edge. Okay? A2 to 1 is how much? There is no directed edge. This will also be infinite. Plus A1 to 3 is how much?
8.
8. A1 to 3 is 8. So this is infinite, and infinite plus infinite is also what? Infinite,
Infinite.
right? So if I enclosed this and just take the minimum value from this, what I get? Infinite only.
Yes, sir.
So can I place infinite here?
Yes, sir.
Yes, sir.
मतलब 2 to 3 वाया 1 भी मैं जा नहीं सकता हूं अभी at this instance. There is no path from 2 to 3 via 1. Tadib, are you following?
Yes, sir.
So if this thing has to be generalized, if this thing has to get generalized, can I write it in this way?
So like
A
if we are
of,
doing,
sorry,
sir, if we are doing for node 1, then uh, there should not be any other node in between.
yeah, there should not be any other node. If it is for node 1, then all the entire matrix will be calculated via 1 only. Either direct edge or via 1. Whichever is smaller, that will be considered.
Okay, sir.
So,
Yes.
and this now 2 to 1, the direction is opposite. So it doesn't have a value. So we made it infinite.
Yeah. If there is no weight assigned for such uh, path, it is infinite.
So there's no we can take 2 to 1. If the direction is also opposite, but still we can use it.
We are not using it, no? कहाँ use किया मैंने infinite लिखा है.
लिख सकते हैं वाया 1 के लिए.
2 to 1 मतलब फिर से पूछो.
So now we know कि 2 to 1 तो नहीं हो सकता क्योंकि डायरेक्शन ऑपोजिट है. But लिखते समय while calculating the minimum, we can use it.
We are not using it, no? We have taken infinite.
So we are writing it like a of 2 to 1 plus.
हाँ वैसा मैं वही फॉर्मूला लिख रहा हूँ अभी.
Okay.
Nothing happens without a formula. So before writing the formula, I just took one sample, and then based on that sample, I am generalizing it into a form of formula, and then this formula is nothing but the algorithm.
Okay.
The entire algorithm is based on this formula. In your code also, if you write this algorithm, the code will function. The formula says a of I comma j, that means cost of reaching from I to j can be considered as the minimum value from the cost from a of I to j, or a of I to k plus a of k to j. Either you go from direct I to j, or you go via k, some other node. Whichever is smaller, whichever is minimum, take that value and assign it to this. Now can you relate it with the formula?
Yes, sir. I is 2 here, J is 3, and K is 1.
Yes. So in this example, I is 2, j is 3, and k is 1. Let's try to find out the other value.
A
So
will
maybe
be a raised to power.
Sorry,
So whatever the power of A will be, that will be K.
whatever.
The power of not like A of 1. So K is 1.
Yes.
So yeah, it's not in the power of one. It's just a way of writing it.
Yes, yes.
This is actually we are finding out कि via node 1 मैं कहाँ पर जा सकता हूँ with the shortest path or shortest minimum cost. देखो और अपन कैलकुलेशन करते हैं, आपको और आगे धीरे धीरे समझ में आएगा. ठीक है. नाउ आई एम कैलकुलेटिंग 2 to 4. Okay. Now calculate 2 to 4. So A of 2 to 4. What we are calculating? We are calculating the cost of reaching from 2 to 4 if if 1 is my intermediate node. So whichever is minimum from 2 to 4 and from 2 to 1 and 1 to 4, we'll consider it. So minimum of A of 2 to 4 comma A of, so let me write here as, yeah, so 2 to 1 plus A of 1 to 4. Now what is the cost? 2
1.
to 4 कितना है?
1.
You can see this matrix. 2 to 4 is how much? 1. It's there in the matrix A0 also. दिख रहा है क्या?
Yes.
This value 2 to 4. Is it 1?
Yes, sir.
So 2 to 4 is 1. Comma A of 2 to 1 is how much? Just see that matrix A0. कितना है? 2 to 1
Infinite.
infinite plus 1 to 4 कितना है?
Infinite.
1 to 4 is also infinite. So minimum क्या दोनों में से? 1.
1.
ठीक है. So मुझे अगर 2 to 4 जाना है via 1, तो मिनिमम कॉस्ट कितना आ रहा है? 1. So I will fill this with 1. Let's calculate one more. Next value is 2 to 5. This one. So let's calculate A of 2 to 5. Minimum of A of 2 to 5 or A of 2 to 1 plus 1 to 5. Can you substitute the values quickly? Tell me.
7 infinite and minus 4.
7 infinite minus 4. So infinite, this is like this. Let's not confuse. Infinite plus minus 4. What is the smaller value? 7 is the smaller.
7.
So 7 here. Next we need to calculate 3 to 2. Isn't it?
Yes, sir.
करो कैलकुलेट, बताओ मुझे क्या क्या वैल्यूज आएगी.
4.
4.
This is 4. Yes, correct. 3 to 4. So A of 3 to 2 is, बताऊं क्या ये सबको? Are you getting this? Akshat, Abhijit, Anushka, do you want me to solve this? Nipun, Naman, Nitya, Tadeep.
Getting, sir.
Do you want me to solve this completely now? Or are you getting it? 3 to 2.
Sir, can you show the above matrix, the one which you made previously?
Yeah.
Sir, both these matrix are same. Like, why we are doing the same process again?
These are not same.
Like in the first matrix, we were getting infinite for second row, infinite 0, infinite 1 and 7.
Right.
And in the second matrix also, we are getting the same values for the second row.
Yes, we will get it sometimes. Now, why we are doing this is because we have to calculate the shortest path among all the pairs. Now, because we are at the first node itself, that's why we are getting the same values. Now, slowly as you move on, we'll calculate the matrices for node 2, node 3, node 4. So ultimately these values will get filled up. Sometimes the values will get changed also. Like for example, 2 to 5 अभी आपको 7 दिख रहा है. Final result में 2 to 5 could be lesser than that, because further solving this, you might come to know in future that there is a shortest path available from 2 to 5 via some other node also. Right now, this 2 to 5 is via 1, but 2 to 5 via 2 can be lesser than this. So we will update this matrix. So automatically by applying this formula, the matrix will get updated. This is dynamic programming. At every sub problem or at every node, we are trying to calculate the matrices and then using that matrices for the further nodes. So अब जो matrix form होगा for A1, that is node 1, we will be using A1 to calculate A2. Then we will be using A2 to calculate A3. Then we will use A3 to calculate A4. Then we will use A4 to calculate A5. A5 में जो आपको मिलेगा will be your final solution. And that final solution will tell you the shortest path from all the pair of among all the pair of nodes.
Yes, sir, got it.
Okay. So yeah, A2 3 to 2, minimum of 3 to 2, and then other one could be 3 to 1 plus A of 1 to 2. This comes out to be minimum of 3 to 2 is how much? 4, and 3 to 1 is how much? Infinite.
Finite.
Plus 1 to 2 is also
3.
3. So minimum is 4. So we'll keep 4 there. Right. What is 3 to 3 is already 0. 3 to 4. Here calculate.
Infinite.
Infinite.
3 to 4 will be infinite, and 3 to 5.
Infinite.
3 to 5 is also infinite. So just place those values here. Now calculate 4 to 2. Calculate 4 to 2, 4 to 3 and 4 to 5. कितना आ रहा है?
4 to 2
सर
7.
5 4 to 2 5 आ रहा है.
4 to 2 5 आ रहा है, करेक्ट है.
5 5.
4 to 3. Please concentrate in the class, otherwise it will take another 1 or 2 hours for you to read the things and again understand what it is been done here.
So -5.
Concentrate. -5 is correct. So you can solve it right now with us. It will save your time. And 4 to 5 is?
Infinity.
No.
1 minute. Sir.
-2.
-2. Let's put
Yes, sir.
the
-2.
yeah, so let's put the values. This is 5, this is -5, and this is -2. Calculate 5 2, 5 3 and 5 4. Five two, 5 3 and 5 4. क्या आ रहा है?
3.
No,
3
sir.
गलत.
Infinity.
Infinity.
They're infinite.
All infinite? Or 5 to 2 is infinite?
5 to 2 and 5 to 3 infinite.
5 to 3 infinite and 5 to 4?
6.
6.
6. So substitute those values, put those values here. Infinite, infinite and 6. So these are the new values that we have got. Okay. Now using this A1 matrix, now calculate it for node 2.
So we have
Our
to
input
take A1 matrix.
Yeah, using A1 matrix, now we will calculate for node 2. So ultimately, we will calculate A2. That means via node 2. So once again, I will form that matrix. Right. Now we are, because we are calculating it from node 2, which columns and rows will remain unchanged?
Second row and first column.
Second row and first column. So अब यहाँ से Sorry, second row and second column,
Second
right?
column, yes, sorry.
Yeah.
The
So this
second column.
second row, this one, and this second column, this will remain unchanged. So just simply, and the diagonal is always there. So just copy all those values.
So this, we won't take the values from the zeroth matrix.
No, zeroth matrix is now done. Now we have reached on node 1. Now we will be calculating to reach via 2 and via 1 shortest path हमें already पता है, मतलब नोड 1 के वाया आप कहाँ कहाँ पर पहुंच सकते हो वो हमने निकाल लिया. अगर नहीं पहुंच सकते हो तो इट इज इनफाइनाइट, अगर पहुंच सकते हो तो जो हमने लिखा है वो मिनिमम कॉस्ट है. लाइक फॉर एग्जांपल 3 to 2 via 1 is 4, which is minimum at this point of time, and 3 to 4 is infinite because we cannot reach. So via 1 हम कहाँ कहाँ पहुंच सकते हैं हमने निकाल लिया, और अगर पहुंच सकते हैं तो मिनिमम कॉस्ट में पहुंच रहे हैं वो वैल्यू निकाल ली. समझे क्या?
Yes, sir.
Now because now we are calculating for node 2, so we'll just copy the values of, can you please tell me what are the values?
So infinite 0,
Infinite, okay, infinite 0,
infinite 1, 7,
infinite 1, 7, and second column
304,
4,
5 infinite.
5. Is it correct, guys?
Yes, sir.
Okay, and diagonal will be 0 only because same node से जाना है आपको तो 0 ही cost रहेगा उसका. Now calculate.
So for first row it is 0, 3, 8, 4 and -4.
Yeah, so what we are calculating A13, A13, 14 and 15. So कितना आएगा? A of 13,
4,
A of 14 and A of 15. This comes out to be how much? 4
-4.
minus
So,
4,
oh sorry sir, 1 and 1, 2, 3, 8 है.
8 है ये second वाला.
Yeah. Yes sir, 1, 2, 3 is 8. No
8,
sir, 1, 2, 3, 1, 2, 3 is 8.
The first.
1 to 3 is 8,
4 and -4.
4 and minus. Is it correct, guys? Please check. Others who are doing it. Tadeep, following this thing now?
Yes, sir.
So I'll substitute the values, and please let me know if you want me to solve it step by step. I can do that. Okay. Next values 3 to 1,
Infinity.
3 to 4, and 3 to 5. 3 to 1 is infinity. Is it correct? 3 to 4,
So 3 to 4 is infinity and 3 to 5 is 11.
3 to 4 is infinity. Check it again.
So it's 5, 3 to 4.
Yes, so 3 to 5 is, sorry, 3 to 4 is 5, and 3 to 5 is 11. Next values is 4 to 1, 4 to 3, and 4 to 5. बोलो क्या आएगी निपुण? नो रिस्पॉन्स. नमन,
Getting.
सुमेश, no response from your end.
So 4 to 1 is 2.
4 to 1 is okay. 2.
4 to 3 is -5
4 to 3 is -5
and -2.
and minus 2. So yes, it is correct. 2 minus 5 minus 2. 5 1
So pi1 will be infinite.
infinite.
Infinite and 6.
Again infinite and 6. Everybody got this matrix?
Yes, sir.
Somesh,
Yes, sir.
got this matrix?
Yes, sir. Got it.
Now, using this, we'll calculate via node 3 now. So now do it fast.
सर ऐसे पूरा नोट 5 तक के लिए करना है.
हाँ इसलिए बोल रहा हूँ फटाफट लिखो रहो. अगर आपको समझ में आया तो मैं सारा एक सॉल्यूशन लिख दूं. If you all agree.
सर
अभी 3 के लिए है तो कौन सा कॉलम फिक्स रहेगा?
Third
थर्ड रो
row and
एंड
third
थर्ड
column.
कॉलम.
Third row, third column.
So third row is 8, infinite 0, -5, infinite, and this is infinite 4, 5, 11. Diagonals will remain as it is. So calculate the values fast. These values. Done.
So just a minute.
Tadib, are you solving it or no? Muskan, Tadib.
Yes, sir, solving.
Tadib, I guess, is not there on the call also. Nitya, Falguni, Shambhavi,
Yes, sir. Solving.
divide it among yourself. You can take one each one is to each student one row.
So,
Could be faster. Okay, tell me what's the thing?
Sir, in the first row will be 0, 3, in 8, 4 and minus 4.
4 and minus 4. Okay. Correct.
Second
Next.
row will be infinite, 0,
Hmm.
infinite, 1 and 7.
Infinite 0. Okay.
1 and 7 are the last values.
So 3, 4 minus 4. 7. Yeah. Next.
Next, fourth row, 2, minus 1
2 minus 1
and minus 2.
and
Minus
minus 2.
2.
Okay, correct. Next.
Infinite, infinite and 6.
6.
Infinite, infinite and 6. Correct. Now, similarly, we'll calculate A3 and A4 also. Sorry, A4 and A5 also. So now I'm writing the final solution. Okay. You can compare it later. So via node 4, that means for node 4, 1, 2, 3, 4, 5. In this case, fourth row will remain the same. So fourth row will remain same, and fourth column will remain same, and the fourth row also will remain the same. Diagonals will always be 0. And then if we calculate the values of, if we calculate all the missing values, which is this, the matrix that we get is like this. And again, further solving this for A5. In this case, the fifth row will remain the same. And fifth column will remain the same. And diagonals will be 0. We'll calculate these missing values. And after calculating, the final solution that we'll get is this one. You can solve it later and you should get this matrix. This matrix is nothing but gives you the shortest path from all the nodes among all the pair of the nodes actually. So 1 to 1 is 0, 1 to 2 अगर आपको जाना है तो shortest path would be 1. Yes, guys, can you analyze the results? Ananya?
Yes, sir.
Muskan,
Yes, sir.
Fatmi? Can you see in the graph the shortest path for reaching 1 to 2 is 1?
Yes, sir.
How, I mean, through via which nodes? Let's take a case study of 1 to 2. Directed edge कितना बोल रहा है? 3.
Yes, sir.
But if I go via 5, so 1 to 5, 5 to 4, 4 to 3, and to 1. Just calculate. 1 to 5 is minus 4.
5 to 4 is
5
6.
to 4 plus 6. 4 to 3 is minus 5. And 3 to 1 is plus
8.
4. If you calculate this, it comes
3
out to
to
be 1.
1.
1.
Likewise, you can check for any of the combination for the shortest path. Understood everyone what we did here?
Yes, sir.
Yes, sir.
Any question?
No, sir.
Nipun?
Yes, sir. No queries.
So, like in practically, these negative edges would be what?
No, practically these negative edges are nothing but see, in practical, cost doesn't mean anything actually. It's a matrix.
Yes, sir.
So just a vector, nothing else. A vector matrix. So minus doesn't means anything in real time. Distance cannot be negative, time cannot be negative. It's just a simple matrix to understand the problem.
So still this would be the shortest path.
Like,
In practically, if we would use this to solve some things, so it would give the shortest path.
yes, it would give the shortest path. But this is giving the shortest path among all the pairs.
Yes, sir.
Like 1 to 2 भी shortest path दे रहा है, 1 to 3 भी दे रहा है, 2 to 1 भी दे रहा है.
Yes, sir.
Like from 1 to 2 it is 1, but from 2 to 1 it is 3.
Yes.
You see it?
Yes, sir.
Right? See, it is giving you the shortest path among all the pairs. It's not like कि एक ही बार दे रहा है सिर्फ. Dijkstra's क्या करता है? Dijkstra's एक ही नोड से shortest path निकाल के देता है.
Yes, sir.
अगर आपका कोई प्रॉब्लम स्टेटमेंट है and in that problem statement or in that project if you want to calculate the shortest path among all the nodes, then this is the algorithm which you should implement. And this algorithm is nothing but take the matrices as input. I mean, take the graph as input in the form of matrix and just apply this formula over it in a for loop. It will give you the result in just few lines of the code. The numerical looks big because of the calculations, but the programming is very simple.
So like here you said it is giving different for 1 to 2 and 2 to 1. So why is it so? Like
Because
the
of
path
the
should be same.
because of the directed graph. Because 2 to 1 there is no edge, direct edge.
Yes, sir.
So it is going via some other node.
So maybe in undirected graph it would give same.
Yeah, in undirected graph it would give same.
Okay.
But ultimately at the end, after applying this formula, you are getting the shortest paths among all the things in the directed graph case. फाल्गुनी समझ में आया? नित्या, शांभवी?
Yes, sir.
Okay. So do you want to practice it with a different problem?
So as an homework,
Huh?
as a homework,
Yeah, as a homework. Please. So maybe you can take this graph and solve it. It is a smaller graph, so it won't take too much of time. Take this graph as as a solution, as a homework. Maybe you can solve it on paper and submit it as a discussion. I'll open the discussion. You need to submit it there.